This video is a video that gets us going in the second half of the chapter for chapter 2. So the very first part of this chapter, the whole first half, has been about parabolas. We have written parabolas in 3 different forms. We've learned how to graph. We actually even reviewed how to solve quadratics and how that relates to the x-intercepts. And so the second half of this chapter, we're going to continue to talk about transformations, but this time we're going to start transforming different parent functions other than parabolas. So the purpose of this activity is for you to explore different parent functions. There are 6 parent functions that you are responsible to learn. And in this activity, we are not using technology for this exploration. So in this exploration, the very first function is a quadratic. So I thought we would start with a review. Now, the parent graph equation for a quadratic is y equals x squared. Now, if we think about what the outputs are, if the inputs are these, we could complete a table. Now, if we plug in -2 here, -2 times -2 is 4. -1 squared is 1. 0 squared, 1 squared, 2 squared. So now if we plot those 5 points on the graph, -2, 4, -1, 1, 0, 0, 1, 1, 2, 4. Now, I don't think the table was really necessary for this parent function because, again, the whole first half of the chapter was us transforming this parent function. Now, HK is 0, 0. HK is the vertex. Now, the domain for this, you could plug any real number. So I'm going to put all real numbers for the domain. And the range, all the outputs when you square a number, always positive or 0. So y greater than or equal to 0. All right, so now, what if we wanted to write the graphing form of the parent function? Well, our graphing form was a x minus h squared plus k. And so we can use what we know about h, k, and a to make a graph of this. So this is a transformed parent function. Now, this minus means that the graph is reflected over the x-axis. In other words, it opens down instead of up. This +2 means the graph is shifted left 2 units. And the +4 means the graph is shifted up 4. What graph are we talking about? This graph, the parent function. So this graph right here would look like this. We have a vertex at -2, 4. And it opens down in the pattern 1, 3, 5. Over 1, down 1, over 1, down 3, over 1, down 1, over 1, down 3. And there is your transform parabola. Now, our new value of HK, that is still the vertex, -2, 4. Now, the domain of this one, you can still plug in any number for x. So the domain is still all real numbers. But the range, notice the y values are all below, 4? Okay. So nothing new with page 1. All right. But what we're going to do now is do this very activity with 5 more parent graphs. All right. Absolute value function. The parent graph for absolute value, y equals the absolute value of x. Now, back in algebra, you learned a bit about how to solve absolute value equations. And so consider this. Absolute value means distance from 0. Distance from 0. That's what absolute value means. So how far from 0 is -2? 2. How far from 0 is -1? 1. How far from 0 is 0? How far from 0 is 1? How far from 0 is 2? Now, when we plot these points, -2, 2, -1, 1, 0, 0, 1, 1, 2, 2. There it is. There's your parent function. All right, now HK, 0, 0. Read HK off of absolute value just like you would off of a parabola. And the domain, you could put any real number in for X, all real numbers, but notice the range, the outputs are always positive or 0. Now, graphing form of a parent function, just as it would be for parabolas, y equals a, absolute value x minus h plus k. So we can transform this just as we transformed a parabola. And we have, again, an AH and K. AH and K does to absolute value what AH and K did to parabolas. So let's describe the transformations. A is positive, so our V opens up, but this 2 means it's a vertical stretch of factor 2. So this -4 means the absolute value, the V-shaped graph, is going to be shifted right 4 units, and this +1 means it's going to go up 1. So let's make our graph. The point of the V, the vertex, 4, 1, 1, 2, 3, 4, 1, and again, vertical stretch of 2. So what happens here is these Y values become twice as big. So this 1 becomes 2, this 2 becomes 4, this 3 becomes 6. So instead of going over 1, up 1, over 1, up 1, it's going to be over 1, up 2. So from the vertex, over 1, up 2, over 1, up 2, over 1, up 2, over 1, up 2. An absolute value graph is also symmetric, but it's a V instead of a U. So there is our vertically stretched parent function shifted right 4 and up 1. So HK is 4, 1. The domain is still all reals. You can plug in any number for X and get an output, but the range, the outputs are all above or equal to 1. Okay?